Today we need to cover some basic rules of integration that are very important. And I told you to look at page 289 in your textbook, table 6.3. That's where these rules are. And we're going to kind of work through some of them. Some of them we've already covered. But then you're going to see some situations where they show up. So, the first one says that the integral from a to b, remember integrals are areas. So if I have an integral from a to b, I'm calculating an area from a to b of f of x dx. Number one says that that is the same thing as the integral from b to a if I just multiply it by -1. Okay? So in other words, number one says I can switch the limits of integration. I can switch a and b if I multiply by -1. Okay, that's what that rule of integration says. And boy, does that come in handy sometimes. All right, that's a nice rule. Okay, we'll use that in a minute. The second rule. Now, you know, sometimes you have to use common sense, but sometimes that common sense avoids some of us. So, for those of us that struggle with common sense, we get rules that help us. The integral of a function from a to a. Well, if there's no interval, I mean, if I'm going from a to a, there's no area. This is 0. Okay? Number 3, we already covered. Number 3 is the constant multiple. But I do want to kind of remind you of it. Okay? Number 3 says that if I have the integral of k times f of x dx, that's the same thing as k times the integral of f of x dx. It works just like it does with derivatives. Okay? The constant just comes along for the ride. It's multiplied at the end. All right? Don't leave that out. Number 4, we already covered. Number 4 says that I can split up an integral into pieces. All right? We said, you know, for example, we said if I've got the integral of 3x cubed plus 5x squared dx, we said that I could split that up into two separate integrals. The integral of 3x cubed plus the integral of 5x squared. All right, that's what that number 4 says. Okay. Number 5 we haven't seen yet. Number 5, I want to kind of go a little bit more slowly on. Number 5, before I write it down, let me just kind of draw a picture here. If I had some function, all right, and here's A, here's B, and here's C. Remember what an integral is. It's the area between the curve, between the function, and the x-axis. If I wanted to find this total area, what number 5 says is that I can break it up into 2. I can make the integral from a to b of f of x dx plus All right, what did we do? We did the integral from a to b. That's this. Plus the integral from b to c. So this will be the integral from b to c of f of x dx. And of course, that's going to be equal to the whole thing, right? It's going to be equal to the integral from a to c of f of x dx. Okay? Now, here's what happens though sometimes. Sometimes they combine rules. All right? So let's make a note here. Note. Let's do Rule 1 and Rule 5 combined. So, what am I saying here? Well, if I have the integral from a to b of f of x dx plus the integral from b to c of f of x dx. Didn't Rule 1 say that I could switch the limits of integration if I put a negative in front of it? Well, guess what? If I switch the limits of integration on this integral right here, then I could write this as this integral, the integral from a to b. The first one stays the same, minus the integral from c to b. And in that case, we combined two rules. We put two rules together. All right? And that's going to actually crop up some in some of your homework. We need to get to some examples. All right, one other thing I want to point out about this equality statement, and maybe you didn't see that this was the equal sign. These two things right here are the same. I could have switched the limits of integration on this one too, so long as I put a negative out in front of it. All right, let's get to an example. One of the things they're going to do tonight is they're going to give you some information. So I'm going to say given. They're giving you three pieces of information. Number one, the integral from -1 to 1 of f of x dx equals 5. Okay, they give you that. They tell you that the integral of the function from -1 to 1 is 5. Then they also tell you that the integral from 1 to 4 of f of x dx is -2. And one more piece of information they give you. They tell you that the integral from -1 to 1 of h of x dx equals 7. Okay, so that's given information at the beginning of the problem. They give that to you. So now they say, now we actually do the problem. Okay, so here's the problem. Well, we'll say problems. We're going to do a few. They're going to ask you to do several problems from that given information. Number one, what is the integral from 4 to 1 of f of x dx? We don't need a function. Okay? We don't need a function. So look, wasn't I given what the integral from 1 to 4 was? Right? Didn't they just flip the limits of integration? So don't I just multiply by negative 1? So this is going to be equal to negative 1 times the integral from 1 to 4. So they told me that this is negative 2. So negative 1 times negative 2, the answer is positive 2. Now I know maybe we didn't have to show all those steps, but I'm here to explain things to you, so that's how I arrived at that answer. Let's do another one. These are problems. Well, what if they asked you to find the integral from negative 1 to 4 of f of x dx? Now, I wasn't given information about negative 1 to 4, but you got to think, you have to think graphically here. Here's negative 1, 1, 2, 3, 4.
If you add negative 1 to 1.
Can't I add two of the pieces of information I got together? Look, I was given what the integral is from negative 1 to 1, and I was given what it is from 1 to 4. So using that additivity rule that we just learned, I can add the two together. All right? So this is the same thing.
Tyler Johnson.
I can rewrite this as negative 1 to 1 of f of x plus the integral from 1 to 4 of f of x. What did I do? I split it up as the integral, whatever my function is doing, I split it up as the integral from negative 1 to 1 and then the integral from 1 to 4. Okay? And that additivity rule says I can do that. And now I've got all the information I need. Negative 1 to 1, it's 5. 1 to 4, it's negative 2. So I just have 5 plus negative 2, and the answer is 3. Okay? One more. What if they said, what's the integral from negative 1 to 1, and then they put this ugly bracket here, 2f of x plus 3h of x dx. Well, this one's not hard either. Don't I just have a couple constants up there? And I've got a sum. So, in reality, what I've got here is 2 times whatever the integral from negative 1 to 1 of f of x is, plus 3 times the integral from negative 1 to 1 of whatever h of x is. Left off my dx here. AP calculus people get mad about that, so we better put that in. So, don't we have all this information? Let's go back to what I was given. I've got it all. I've got the integral from negative 1 to 1 of f, and I've got the integral from negative 1 to 1 of h. Okay, so I put them in. One of them is 5, the other one's 7. This one is 5. This one is 7. And I just need to multiply them. 2 times 5 plus 3 times 7. 10 plus 21 is 31. Make sense? Just using the rules. Okay. Now, how about this last one? Sorry for my crunching. I'm crunching a cough drop. Now, you have to keep in mind that sometimes you might not have enough information. Do I have enough information for this one? Was I told anything about an integral from 0? No. Can't do it. And that will happen. Okay? Okay, somebody asked on this problem, could I have done the integral from -1 to 1 and then just divided the whole thing by 2, since I'm going from 0 to 1? And the answer on this problem is that there's not enough information to do that. It is conceivable that if I was doing an even function, remember our old friend x squared? If I knew that the function was even, there is a rule for that. In this case, if that would have been my function, then yes, I could have just taken what it is from -1 to 1 and divided it by 2. But I was not given any information about what f of x is. So we can't just divide it by 2. Good question. Now, the last thing for today. The average value of a function. You know, let's think about averages for a minute. If you got 4 test scores, okay, how do I find, and remember, average is another word for mean. If you had 4 tests, let's say you got a 78, an 89, a 91, and a 94. How would I find the average? I would have to add all of those up, right? And divide by how many I had, right? Well, what is an integral? Haven't we been adding things up? Didn't I tell you that an integral is a sum, right? I'm letting the number of rectangles go to infinity, okay? I'm adding up an infinite number of rectangles. So guess what? I can do an average value of a function if, now you told me that I divide by how many there were. All right, well in this case, I'm going to divide, or in other words, multiply by 1 over the difference between the limits of integration. Okay? It's just a simple formula. This is the formula for the average value of a function. And it's a lot like a regular old average, because remember, an integral is a sum. Okay? So, if they ask you to find the average value of f of x equals 4 minus x squared on 0 to 3, and then they said, does it attain this value? Somewhere in the interval. This is actually a very easy problem. If you see one like this, you're going to like it, because all you have to do is use our formula. 1 over b minus a times the integral of a to b f of x dx. Well, what's my a and b this time? It's 0 and 3. So this is going to be the integral from 0 to 3 of 4 minus x squared dx, okay? But it's going to be multiplied by 1 over 3 minus 0. Now here's what I'm going to tell you tonight. We're going to work later with how to actually do this analytically, but tonight you can use the numerical integer function of your calculator that I showed you. Okay? What I'm going to tell you is that in this situation, if you do this on your calculator, okay, use the f&int feature of your calculator, you're going to find out that this thing is 3. Okay? But what are we multiplying it by? Don't I need to multiply it by 1/3? So it's going to be 1/3 times 3, which is going to be 1. And that's your average value. Now, to do the second half of the problem, which I don't need to finish, does it attain this value somewhere in the interval? All you have to do is set the function equal to that average value and solve it. So to do the second part, you would set 4 minus x squared equal to 1 and then solve. And we're going to stop there for today.